Hello, my name is Honglu Zhou. I am a senior undergraduate at Communication University of China, majoring in computer science and technology. The objective of this video is to introduce my artificial intelligence-related research work. My research background is in artificial intelligence. Specifically, I have conducted research on genetic algorithm, particle simulation algorithm, and neural network. I have published one paper researching on genetic algorithms at the 5th IEEE ACS International Conference on Computer and Information Science. I have submitted my second paper to Journal of Applied Soft Computing, which is a comparative study of genetic algorithm and particle simulation algorithm. I participated in the National Undergraduate Scientific and Technological Innovation Program in my junior year. The name of the project is Research and Application of Evolutionary Optimization Algorithm. I focused my research on using genetic algorithms to solve traveling salesman problem. The objective of basic traveling salesman problem is to find the salesman's route with the minimum cost, under the condition that this salesman must travel all of the given locations for only once and return to the starting location in the end. Many real-life problems can be modeled as traveling salesman problem after transformation, such as path planning, production scheduling, and network communication. Traveling salesman problem is a famous mathematical problem and a typical combinatorial optimization problem. However, a company may have more than one traveling salesman, and there may also have some other rules like the minimum tolerance for every salesman. In real-life applications, express delivery companies send packages to multiple locations. In order to ensure that each courier's workload conforms to the basic wages, the company may set some regulations like each courier's least travel distance. The basic traveling salesman problem cannot be used under this circumstance. Therefore, multiple traveling salesman problems is introduced. In my research, I changed the single salesman condition in the basic traveling salesman problem into several salesmen. The minimum city number restriction that each salesman must go through is used. Practice has proved that genetic algorithm has a good effect on solving traveling salesman problem and other combinatorial optimization problems. Yet, classic genetic algorithm cannot solve multiple traveling salesman problem perfectly, because sequence encoding method is the most suitable method and is often used to solve traveling salesman problem. However, if we use sequence encoding method and if we still use a traditional crossover operator in genetic algorithm that crosses to individual at any position directly, it will generate individual that is meaningless and illegal as it cannot satisfy the problem requirements. As a result, when using genetic algorithm to solve traveling salesman problem, it is necessary to use some special crossover operators. But the drawback is that those special crossover operators are often too cumbersome to implement, and gene combination or parent chromosome might be disrupted during the operation. Therefore, I chose to use a parthenogenetic algorithm instead of the classic genetic algorithm. Parthenogenetic algorithm abolishes crossover operation and replaces it with a variety of mutation operations. The rest process of parthenogenetic algorithm is the same as genetic algorithm. It has many advantages. Some researchers have questioned the role of crossover operator and believe that it does not have a significant role in the optimization of population. So, I use parthenogenetic algorithm to solve the multiple traveling salesman problem with the constraint of the minimum tolerance for any of the salesmen. I firstly proposed one parthenogenetic algorithm with conventional roulette selection and elitist selection, in which 4 new kinds of mutation operations are proposed. However, this parthenogenetic algorithm is mutation probabilities, and appropriate values have to be set in advance, and it uses a roulette selection which is too random, and elitist selection can only prevent outstanding individuals from accidentally being eliminated in the process of replication. But still, relatively good solution with high fitness value is easy to lose. Moreover, random mutation may cause the genetic characteristics of the chromosome to be easily damaged. Thus, invalid mutation gradually increases along with the solution become more optimized. Overall, I believe that the genetic operation of this particular genetic algorithm is not good enough, making it unable to improve the quality of the solution even if we increase the number of iterations. Design better selection of mutation operators or combine some other good local search algorithm properly can effectively overcome the problem. In this regard, I propose an improved particular genetic algorithm. The improved particular genetic algorithm binds the selection and mutation together. A new selection operator and a more comprehensive mutation operator are used. The more comprehensive mutation operator bases on the four kinds of mutation operations in the first particular genetic algorithm and abolishes the mutation probability. The improved particular genetic algorithm optimizes the genetic operation and further improves the search ability, avoiding the trouble of parameter setting and making the original algorithm most efficient and stable. Particle swarm optimization algorithm is a popular swarm-inspired method and a stochastic optimization technique which is developing rapidly in recent years. I also adopted particle swarm optimization algorithm to solve the multiple traveling salesman problem as a comparison. Standard particle swarm optimization algorithm considers each individual as a particle. The positions of the particles are potential solutions to the problem. The velocity of the particle changes the position of this particle. According to the formulas, particles update their velocities and positions. Adopting particle optimization algorithm to multiple traveling salesman problem, it is necessary to rewrite the standard particle optimization formulas. In order to let the particle can learn from its current best position and the current global best position, I propose three new operators and new particle optimization formulas. In my second paper, which is submitted to Journal of Applied Soft Computing, I put forward three theories of comparative experiments on particular genetic algorithm, the improved particular genetic algorithm, and particle optimization algorithm. The algorithm validity test is to test each algorithm's validity. I used test data from TSP-IRB, which is a benchmark of traveling salesman problem with empirical results. Among the three algorithms, the result of the improved particular genetic algorithm is really close to the optimal solution in TSP-IRB, so the improved particular genetic algorithm can solve traveling salesman problem most effectively. Experiment 2 compares and analyzes three algorithms mainly from the angle of the algorithm performance. In this experiment, I compared the convergence ability, the efficiency, and the quality of the solution of the three algorithms, and then discussed and analyzed the reasons. The results show that the improved particular genetic algorithm is the best. In the last experiment, I studied how the number of salesmen and the number of cities will affect the solution. It can be found that a bigger number of salesmen does not necessarily generate a better solution. So, for a multiple traveling salesman problem with given number of cities, we can determine an appropriate number of salesmen combining with other factors. From this research, I gained some thoughts. First, particular genetic algorithm is not perfect and sometimes it will take a long time to converge to the global optimal solution from local optimal solution. It is because particular genetic algorithm only uses mutation operator. Invalid mutation becomes more and more, and the evolution of the population becomes more and more slowly with search advancing. Second, genetic algorithm and particle optimization algorithm often encounter the weakness of premature convergence and the poor convergence ability. It is necessary to prevent such phenomenon. Third, particle optimization algorithm is suitable for solving continuous problem, but genetic algorithm may be more excellent for solving discrete problem like traveling salesman problem. Sometimes it can be troublesome for genetic algorithm and particle optimization algorithm to solve constraint optimization problems. I have been serving as a research assistant for Professor Mingli Song for the National Natural Science Foundation project. I built a multilayer perceptron in my lab without using the neural network toolbox. This fully connected multilayer perceptron is trained by error propagation. Additionally, the number of hidden layers, the number of neurons in the input layer, output layer, and each hidden layer can all be set optionally. So this multilayer perceptron can have any number of layers and any number of neurons. As a result, it is applicable to all kinds of regression and classification problems, such as projecting Hom values and Iris flower classification. Moreover, parameters like the learning rate, the threshold condition, and the number of iterations can also be manually set. My current research efforts and graduating thesis center on facial recognition. I'm planning to take the convolutional neural network approach. Convolutional neural networks are generally trained by error propagation. However, backpropagation algorithm actually has some drawbacks. Backpropagation algorithm deterministically occurs in local optima, making it hard to get global optima, especially if a large search space is required for optimal solution. The algorithm is also slow and cannot fully utilize the benefits brought from using modern machines such as GPU, which runs hundreds to thousands of threads simultaneously. Third, the complex computational equations emerging in the algorithm demand hard and complicated series of steps to find derivative equations for updating with parameters. Finally, backpropagation algorithm requires keeping forward and backward essential parameters used for updating equations, meaning that it needs many variables to preserve intermediate data. On the other hand, genetic algorithms investigate the entire search space, making it easier to get global optima, and genetic algorithms show the robust parallel ability, suitable for using GPU to accelerate the algorithm speed. Considering the shortcoming of backpropagation, which trains the convolutional neural network in facial recognition, and the advantage of genetic algorithms, I have decided to implement 4 contrast experiments. First, convolutional neural network trained by backpropagation. Second, convolutional neural network trained by genetic algorithm. Third, convolutional neural network first trained by backpropagation, then fine-tuned by genetic algorithm. First, convolutional neural network first trained by genetic algorithm, then fine-tuned by backpropagation. Additionally, I have already come up with the algorithm process of using genetic algorithms to train the convolutional neural networks. The goal is to explore the possibilities of using evolutionary algorithms to improve the performance of convolutional neural networks. Right now, I'm reading the source code of Caffe and trying to do the experiments. That's it, my artificial intelligence related research work. Thank you for your time.